Hello students, we were discussing about the alternating current chapter. We have discussed about the AC voltage applied to resistor, capacitor, inductor that we have already done. Also we have discussed how to calculate the power supplied to a resistor, capacitor and the inductor. Also I have given in the last class about the impedance, what is called as the impedance. Next topic that I am going to discuss it today is about the LC oscillation. This is a LC circuit. Okay, so this is a capacitor, this is an inductor. And when we connect a L and a C circuit, that type of circuit is called as a tank circuit. This is called as a tank circuit. Now what is the LC oscillation represents? That part is it. LC oscillation, if you consider it here, LC oscillation converting a magnetic energy into electrical energy, again from electrical energy to the magnetic energy, that conversion is called as a LC oscillations. Now let us check how the LC oscillation occurs in this tank circuit. First of all, what we have to do, you have to charge the capacitor. As we know, the capacitor has a property that firstly it gets charged fully. After it gets fully charged, it discharges the charges from the capacitor. And when, as we know, if a charge is closed, then there will be a flow of current in the circuit. Okay. Then, when you charge the capacitor, the energy that will be stored in the capacitor, okay, the energy that will be stored in this capacitor, that will be your electrical energy. This is your electrical energy. First, when you charge the capacitor, after charging the capacitor, then the capacitor will start discharging. So the current will be flowing through the circuit. Suppose this is your current flow. It is flowing through this inductor. So when the current flows to the inductor, as the inductor has a property of self-induction, it will allow the current to increase in steps. With that, there will be a change in current, and with the change in current, there will be a change in magnetic flux. And with the change in magnetic flux, there will be a production of induced EMF also. We will not going to induce EMF, we will be going to magnetic field. So that current that will be flowing from here, it will be flowing to the inductor, and that inductor will be converting that electrical energy into magnetic energy, because here the energy that is developed, it is your magnetic energy. Okay, so magnetic energy will be developed, so magnetic field will be created here. Yes. Then after that, after the capacitor gets fully discharged, then what will happen? Whole of the electrical energy will be converted into magnetic energy. Clear? After the magnetic energy it is fully done, this here the charge will be equals to 0. After that, when the inductor gets fully magnetized, then the inductor starts demagnetizing. Okay, it will start demagnetized. So it will be starting demagnetized, and with the process of the demagnetization, this capacitor will be getting charged at the process of discharging. At the process of demagnetization, this capacitor will get charged. Okay, that means whole of the magnetic energy now slowly it will be going on converting into electrical energy. So the full magnetic energy in the next step will be converted into electrical energy. This cycle will continue in this way. One will charge the other one will charge the other. Okay, so it will be going on that way. This is how the conversion of energy takes place. And this is called as the LC oscillations. This is how the LC oscillations occur. Okay, so in the next class we'll be discussing about one more topic related with the alternating current, that is about the transformer. We'll be discussing in the next class, and then after that 2 or 3 more definitions will be left out, so we'll be doing in the next class. So after that there will be your syllabus for the cycle test 2. Thank you for today. We'll be continuing in the next class.